Hello everyone, I'm Yiying Zhang. I'm assistant professor from UC San Diego. Today I'll be talking about user-defined cloud. This is a joint work with Professor Adlan Amiri Sani from UC Irvine and Professor Harry Shi from UCLA. Cloud computing is no doubt one of the biggest markets in the computer industry today. Since the launch of AWS in 2006, 15 years have passed. Cloud computing has evolved from a simple service that just runs computers to a sea of services. Today, AWS has 175 services, and just within EC2, there are 331 instance types. If we look at the past 50 years, cloud computing has evolved following this common pattern. A cloud provider first identifies a new type of popular application or hardware. Then the provider develops software or hardware infrastructure for these trends. Finally, it launches a new service or extends an existing one. With the success of cloud computing, this model has been taken for granted. But can there be any problems? Let's take a look at an example in the health industry where a hospital is trying to move its digital data and computation to the cloud. This hospital first wants to migrate its patient medical records to the cloud and to store it securely and with privacy, and do the same for medical images as they are generated. Next, the hospital wants to combine these data sources and perform certain machine learning tasks so that it can help doctors with real-time diagnosis. Finally, it wants to combine medical records with public data like weather forecasts to perform certain data analytics to come up with a plan for its own staffing. So what this hospital needs from the cloud is to securely store medical data and to securely process them on accelerators like GPU. And for certain processing, the hospital desires to perform in an on-demand fashion, for example, when images are taken. But if you look at today's cloud, there's no option for on-demand accelerators. What this hospital can do then is to just maintain VMs with accelerators so that when images are taken, it could be processed immediately. But then when there are no images, the hospital is paying extra for these VMs. Another problem is that today's cloud has no secure accelerator. And then this hospital has to use secure CPU, but then to suffer from certain performance loss. Another need that this hospital has is to use different consistency levels and replication factors for different parts of the application, because an application like this is complex. But if you look at today's cloud, there's no way to fine-grain tune systems features. And what is left for this hospital is to combine a set of services and build its own platform. What this example tells us is that with today's cloud computing model, there often is no right service for niche applications. As a result, users have to build local clusters or use third-party services. The root cause behind this is a disconnection between cloud providers and cloud users. What's happening here is that cloud providers define the cloud to accommodate the user needs they deem popular. But users are the ones who know what is needed to run their workloads, and we should let users get what they need. So our idea, based on this observation, is to let users define the computing resources and features of these resources for their own workloads. And to avoid adding IT burdens to users, we want cloud providers to continue supplying software and hardware infrastructures under the hood. With these ideas, we propose user-defined cloud. Specifically, users can first define their own application semantics, and then they can specify different types of hardware resource, execution environments, security features, and distributed semantics. As some of you might have noticed, certain specifications are quite low level. So what we imagine the usage model is that the user has two teams. The developer team is responsible for developing applications, and afterwards, an IT team would go look at this application and come up with a set of specifications. Under the hood, the provider still manages and provides software and hardware infrastructures. So now let's take a closer look at what can users define. And again, let's use the same hospital application. So the first thing the hospital can define is application semantics. And they can define their own application as modules. For example, they can define data modules like medical images and medical records. They can also define processing modules like image pre-processing and image classification. And then they can combine these modules into a DAG. And finally, they can specify the triggering events which would trigger the execution of their application. Next, the IT team could specify the hardware type that they want to use for each module. For example, they can say that the image pre-processing should happen on FPGAs and image classification should happen on GPUs. And similarly for other modules. In addition, they can specify the amount of resources each module is desired to use. If they don't specify that, then the provider would figure it out automatically. Next, the IT team could specify the execution environment and security needs for each module. So for example, they can say that the medical images and records need to be stored securely with privacy. And they can specify that the image pre-processing and classification happen in a single tenant environment where the hardware resource is only occupied by this hospital, and certain other modules are executed in the trusted execution environment or the combination of trusted execution environment and a single tenant. Finally, the IT team can specify a certain distributed semantics, for example, the degree of replication, where to checkpoint, and the level of consistency. Now that we understand what users can define, let's switch gear and look at how can the provider achieve these user definitions. Our idea here is to develop hardware and software layers in a fine-grained way so that we can put together features for user needs on demand, like assembling Lego pieces. Let's look at how this works, again with the same application. And specifically, let's look at how we can fulfill the needs for these two data and computation modules. Our idea at the hardware level is to disaggregate hardware resources into independent network-attached pools. And then at the system software layer and distributed systems layer, our idea is to develop them in a modularized way so that they can be freely and flexibly combined. Then at runtime, when we need to put together the service for the different modules, we just find the right combination of hardware and system software like this. Finally, let's look at the benefits of user-defined cloud. And let's look at it from two perspectives. For users, the benefits are quite clear. So first of all, most importantly, they get to now customize a public cloud for exactly what they need. And they don't need to wait for providers to prepare new features. What this means for users is that they can launch their applications much quicker and with better performance. In addition, they maintain low IT costs because providers are still the one who build and manage software and hardware infrastructures, and users pay only for what is used. The benefits for providers are less clear and more questionable. But we think some of the potential benefits include, first of all, the provider now only needs to build one set of configurable software and hardware infrastructure instead of sea of services, each of which is a combination of different software and hardware features. What this means is that in long term, the provider could save development and maintenance cost compared to today's cloud computing model. And another potential benefit is that the user-defined cloud could attract more users. And with the benefits, the provider could charge a higher unit price. So together, this translates to more profit for providers. To conclude, we proposed user-defined cloud by giving control to users. We believe that this is appealing for many cloud users, and a lot of the building blocks are already here. So it is the time for actually building the user-defined cloud. But at the same time, it is still questionable how appealing it is for cloud providers and whether the benefits is worth building a whole new set of infrastructures. But we believe these are the reasons for academia to try it out first. Thank you. We are now happy to take questions.